Hello, my name is Ethan Zhu, and this is my research infographic for CEN3031. The title of this infographic is Breaking Bugs: Why Software Testing is the Key to Quality. And the subject obviously is software testing. And here we have the five sections that were required: the problem formation, the literature search, the critical analysis, the evaluation, as well as the most interesting. We have also included the references as a sixth segment, and this just encapsulates all the research papers that we used in the formation of this infographic. That being said, we're going to go right in. And yeah, so the first segment is problem formation, where we go over where this was found in the class, which is chapter 9 of the Somerville textbook. We also go over the definition of software testing, which is the process of identifying and removing defects in software systems. Give a brief overview on the history of software testing, and we also conclude that the rest of this infographic is for the exploration of a brief history of software testing, as well as its overall evolution from past to present. And we also have a little graph here, which kind of shows the distinction between quality and the amount of testing that we do. And we do want to point out that software testing is not about getting perfect code, as that is often very costly and not worth the time, but rather striking a balance between the quality as well as the amount of testing that we do so that we don't overspend in monetary or time-wise manners, and we still get a valid and valuable, accurate piece of code. Moving on from that, we have the second segment, which is literature search, where we provide an overview of the four research articles. Research Article 2 examines the foundational methods that modern testing infrastructure is based on, and it also emphasizes the role of planning and automation in the detection of bugs. Research paper 3 goes over the effectiveness of existing techniques, as well as their significance and how they were built on rudimentary practices, as well as the the purpose of rudimentary practices on modern systems. Research paper 4 provides insights on the past 3 decades of software testing evolution, and it offers a detailed analysis of how these changes have changed along with the internet and the development of technology to our time. Research paper 1 also presents a new modern method as of 2024 that I'll be going over in section 5. Section 3 is the critical analysis, where I've attached a basic model of the STLC, which is also known as the software testing lifecycle. Beyond that, the critical analysis basically shows that there's a growing significance in the importance of software testing, especially as the internet continues to develop, as well as technology. We also link the Jamil et al. Research paper on the groundwork for defect detection and how, as the internet progresses, we also need newer models and more advanced approaches to dealing with software testing. And that's also encapsulated in the second paragraph, basically saying that we can use artificial intelligence and machine learning to create new adaptive testing solutions that comply with our modern needs. And for evaluation, we kind of just summarize everything that the literature describes steps that software testing took to reach its current state, both its foundational as well as its current and evolving nature. From a personal perspective, I think this shift is necessary. However, I do believe that a certain amount of manual testing and oversight is still necessary, as we do not want to place an over-reliance on software as well as AI or ML in order to do our validations. What I found the most interesting was that there was a new method, as I referred earlier to, called self-healing test cases, which uses AI and ML to detect and adapt to minor changes in UI or context. And this basically allows us to automate the change and adaptation of test cases in a minor sense so that we don't have to manually change test cases every single time we make changes. And this would help us reduce maintenance, increase cost efficiency. It'll give us a faster development cycle, will increase the test coverage, and will also enhance the reliability of our test cases. And that is all five segments. Once again, there's a references page for the four research papers here. And yeah, once again, I am Ethan Zhu, and this is my final research infographic. Thank you.